And we are live. So, hello, everybody. Thanks for tuning in to another EKC Construction Technology webinar. I'm really excited to have our panelists today with QNect to discuss a little bit more about their topic, how early connected models are transforming project delivery for data centers and more. So, there's a lot to dig into, and I will turn it over to our fantastic group to give an intro to themselves, and then we'll get right into the discussion. So let's first start with Michael. Intro to
Yeah,
yourself.
yeah. Thank you, Aaron, for organizing this event and hosting this. Yeah, Michael Gustafson, Vice President of Strategy and Business Development at QNect. And yeah, I've been in the tech sector for over a couple of decades, worked at both Trimble and Autodesk, and structural engineer by background.
Awesome. Let's go next. Let's go around my screen here. Chad.
Hey everybody, Chad Arthur. I'm with DPR Construction. Actually spent 12 years in architecture, and I've been with DPR now for about 7 years, focusing on VDC and our design to build strategies connecting design and construction.
Excellent. And then last but not least, Tim.
Hi, thank you for having me here. My name is Tim Scrotenboer. I'm GPLA's Western Regional Manager. I am part of our leadership team, but focus on our West Coast operations and support our team. And I'm based in California.
All right. Yeah, not a bad place to be. I'm out here in LA as well. So, all right. Thank you guys. So I'm going to start off with a question for Michael. I kind of touched on early connected models when I was talking about the topic, but for some of our audience out there, and maybe like people new to the industry, what is an early connected model, and what is early connected model delivery? So let's start there.
Yeah, I think that's an important topic to define. And I'll show a slide here in a second, but the early connected model is really a delivery process. It's an innovative delivery process that shifts a lot of the work streams that are traditionally done, during the pre-construction stage once a fabricator's on board, bringing that upstream and doing it in parallel as part of the structural design. And so if I show this from a visual standpoint, you'll understand the concept here more visually. Can everybody see that screen here?
It is showing a blank. Maybe try one. Oh, there we go. Just took a second to come through. Excellent. Looks great.
Yeah, so this is really I wanted to show this visual so the audience can really understand this shift in work stream. If you see the traditional conventional approach on the upper gray box, that's a timeline. And the connected model, this is the structural steel deliverable that comes after the fabricator is awarded. They build a 3D model to, produce their shop drawings. But the challenge with that traditional approach is all the issues related to connection design and the detailing are figured out way too late in the process. And so that leads to the tradition, everybody's aware of, lots of RFIs, change orders, inefficiencies, and also delays. So the early connected model is a process that, Tim here with GPLA and teams started it's actually over 20 years ago now. It's been in the industry, but really been fine tuned by teams like DPR and GPLA to deliver what you call an early connected model, or high fidelity BIM, I think is their term. It's where you build a 3D technical model during the design phase. So you bring that portion of the work stream up early. And so for data center owners and just really any type of building owner cares about speed to market, this will accelerate the schedule. It'll lower the bids, tighten the bids, and just reduce overall uncertainty in the project.
Yeah, one of the biggest issues in the industry is the disconnect between design and construction, because the designers are often producing drawings and models that only focus on the design intent, and often leaving the means and methods and constructability concerns to the contractors and subcontractors to figure out. And so then this model is then handed off because it's just for intent purposes. It has to be reworked. It has to be redone. And so this process is excuse me, connecting that model together. And so it's one model from the design through construction.
Yeah, maybe Tim, just to add to that, I think that traditionally has existed because, well, design is changing, right? Design is iterative. We don't want to start fabricating or getting into fabrication level of detail because things are going to change. And I think the technology now has allowed us to maintain that connection, maintain the justification lines and the constraints of the engineering intent while simultaneously having that fabrication level of detail to inform the design process at a more detailed level.
Okay. So thanks for kicking us off with, setting the stage there. I want to go next to, Michael, you touched on owners and data centers. They want it delivered, essentially yesterday and very streamlined. What are the benefits to owners when they have this type of model? And feel free, anybody, to chime in.
Well, what we hear a lot from data center owners, and this is similar to some other types of owners, is speed to market. Just being able to
Mm-hmm.
open their facility or start generating revenue as early as possible. And there's a lot of supply chain bottlenecks, right, that kind of hinder that. But one of the key, supply chains on the critical path is the superstructure, meaning the core and shell, if foundation superstructure. And if you're designing that structure like in steel, structural steel, that can be on the critical path. So being able to, eliminate that off the critical path, it really allows the schedule to be at a minimum maintained, but also accelerated through the shift in delivery. So I think that speed is really number one. And we also see, cost certainty, right? Just the bids are tighter, there's more certainty, there's less risk.
Yeah.
And so that's another driver. And I'll just say third, embodied carbon is really top of mind for these data center owners. And so this the process and just the optimization process, can reduce embodied carbon too, which is becoming a higher, importance to
Right.
owners.
So I will just jump in here with one comment. So I see we have a few more joining on the live. So for our audience, if you have any questions, comments, or just thoughts that you want to share on the topic, please do use that comment or a chat box. So we have our panelists' time. They're definitely experts in this topic. So feel free to take advantage of that comment box. So let's jump back in. So, Tim and Chad, I think Michael did a pretty good job of, an overview, but any other details that you've seen that owners have appreciated from this type of project delivery?
Yeah, Tim, I got one. So I think the other thing that this helps us do is when we get into these data modules, hot and cold out containment, or even the cable bus, being prefabricated in some steel coming up the side of the building, getting to this fabrication level of detail allows you to really start to coordinate and plan out some of those supplementary steel members or those tertiary steel members with that initial steel module and or steel package, I should say, based on those module types. And so it really you get into a bill of materials for your steel and all of your metal a lot earlier than you traditionally would.
Yeah.
Which just helps inform the design overall, especially electrical mechanical designs, to really know the most efficient way to build and plan your design of your building.
That's a great one to add. Yeah, you get that list like way ahead of time. And then to what we were saying before, it ties into that predictability component.
Yeah,
100%.
which and we've had the experience on a lot of work, a lot of projects that you have to do that in order for prefabrication to be successful. So some of these early releases of some of these modules that really we're treating like a kit of parts for some of these data centers, you have to do that early in order to allow the time for prefabrication off site in order to not impact the critical path that Michael was talking about earlier.
Yeah, and I'm glad you bring up like critical path and speed to that we're always trying to go faster while still being safer and all these different things that come into construction. Are there any examples of data centers where, you've had to look at the speed of delivery, or where, that was a really important factor? Tell us more. And this is for anyone in the group for sure.
Yeah. I have a recent example. We've done it historically for a giant battery factory in Nevada, but then we've also done it more recently with one of these new AI data center campuses. And the critical path, as Michael pointed out, goes through that steel construction. And so one of the first
Right.
decisions that needs to be made is ordering the steel, getting that mill order in. And so if you have a collaborative team, we were working with DPR Construction and Michael and Connect on this one. If you have that collaborative team, including the contractor, subcontractor, and the owner, making those early decisions, we can accelerate the design rapidly. So in one of these large AI data center campuses, we went to a mill order in 2 weeks from first time to
Wow.
proceed. And then
So
the goal
pausing there,
at that
Tim,
point-
what does it
Yeah,
usually
sure.
take? What does it usually take versus the 2 weeks? Just curious. On like a
Multiple
traditional.
months. Yeah,
I know.
many
I was like,
months.
wait, we need to emphasize this. Like that is, months to 2
Yeah,
weeks.
typically that wouldn't happen until
Yeah.
the design is complete fully, or maybe right
Right.
before you've finished the design, and then you can go to market and reserve your space in the mills. But we went after 2 weeks, and then the goal, and then what was achieved was then finishing the design and the fabrication in 5 weeks, so that by the time the steel was rolled and could show up at the fabrication shops, it could then be put straight into fabrication.
Wow.
So that design to fabrication time was on the order, it was only 5 weeks instead of what typically is a 6 to 8 month process.
Right.
And so you can imagine the savings there is about 5.5 months off your critical path. And that allows that data center to open much, much sooner than anyone would have anticipated, because it's just a concept, and then it's very shortly thereafter things are being moved in the ground and being erected. But it takes that tight integration of the team so that the design is integrated with what the contractor wants to and expects to build. The owner has made the appropriate decisions to release the team to move forward and given the necessary criteria. So it's really a collaborative effort. But if you have that high performing team, you can achieve things that many think are not possible.
Amazing. Teamwork makes the dream work, essentially.
Mhm.
Yeah, I'm still digesting just the amount of time savings. Like that is crazy, especially in an industry where I won't say any of the horrific stats on schedule, but like most projects are over schedule or late. So that is
And this,
a true
yeah,
impact.
this was not a small project. The
Right.
steel that we're talking about here is 8,400 tons of steel.
Right. Yeah.
So it's a
Yeah.
massive scope, and the orders were going to 3 different mills so that we could mitigate the supply chain risks. So that we're looking out. It's just as much about the design as it is about procurement and aligning all of that together. And that's only possible because the design model equals the detailing model. It's all coming from the same platform. There's no handoff and then rework. There's no questions and submittal process slowing things down. Everyone's aligned from the beginning.
That is incredible. Chad, Michael, anything else to add, like specifically on those speed to delivery use cases?
Yeah, I have something to add. So I think one of the things that this process also, just from a behavioral standpoint, and Tim's kind of hitting on it, is we're starting with those details of how it actually wants to be built in the field. We're starting with the fabrication level, how we want a bolted connection, how we want to, where do we really want to weld, and if we have to weld, where is it, and what is that member size going to really be to really erect everything the way that we want to erect it. And so there's not this, well, here's some engineering intent and what works the best for my engineering from an engineering standpoint. Now let's get to your details later to actually understand how you want to truly fabricate it and build it. We're starting with that end in mind, and so it just really is lean. It eliminates a lot of waste in the process, and it's the behaviors plus the technology which kind of enable each other in this process.
Yeah. It's why we say like people, process, technology, and probably in that
Yeah.
order, right? Yeah. So
Yep.
people are really driving the core of it. We follow a process, and then the tech just enhances what we're doing. So
Yeah.
fantastic. So as you were saying all of that, Chad, we got a couple comments in the chat. So I just want to shout out to Dicey. Mitigating supply chain risks equals mitigating business risks. 100%. I think, yeah, we're all nodding our heads. Thanks for contributing that.
Mhm.
And then we have a question from Seth. So, how do you manage the risk of late design changes? What contractual or process safeguards do you put in place to mitigate cost and schedule impacts if the scope shifts after you've already procured long lead items? That's a really good question. And feel free to jump in.
Yeah. Who wants to take it?
Any of you on this one? It's a good one. Juicy question. Thanks, Seth.
Yeah, I'm sure that yeah, Chad and Tim will have some comments, but just from a technology perspective, like Chad said at the beginning, kind of as heading everything off, this process has been used for years, but to be able to do late changes, like that's been kind of the risk of not doing this process because of just design iterations. However, technology, as Chad said, has gotten faster, right? Cloud technologies, as Tim said, using the same platform for design to detailing, like that approach is allowing, this iteration to happen. That's from a technology process, and Tim Chad might say something about, work process as well.
Yeah, and I guess so, Seth. I mean, the reality is you have to be in alignment with your owner, with the client, and their procurement team as well. We there isn't an easy answer to, hey, we thought we wanted to build this, now we want to build something else. That's unfortunately that's just a change in the intent of the building. Um, I do think that there are ways to represent or to build specifically around the structure and steel that allows for design flexibility within that core and shell of the building, uh, while not, pinning yourselves into it has to be this. Well, the structure may have to be that, but what happens within the structure, obviously, if you can design it in a way that's planning for future flexibility, then that makes those changes a lot easier. But the reality is if if you ask for a Toyota Tacoma and you end up with a Dodge Ram later, that someone made that choice, right? They wanted some reason they went away from the Toyota at some point.
And it's a quick process and everyone's aligned. So the fact that if there's a change, everyone can pivot quicker than traditionally too. And and you're only changing one platform and you're not having to go back and forth, but it is getting that alignment between everyone about what is the holistic best answer and way forward, and not, okay, this is the best for structure, and so we're just going to plow forward with that solution. It may not be the best structural solution that we go forward with, but we try to mitigate those issues the best as possible. So in that upfront criteria, what are the things that might change? How can we allow for flexibility, that things might adjust as we go along? And so maybe we're doing big combined pads outside the building for equipment. So if the equipment changes slightly, the pad itself doesn't have to change.
Yeah.
It's not done. It's not sized to a specific unit itself. We've looked and tried to mitigate where those changes might happen, and then provided allowances for them. And then we've also looked into, what if a particular piece gets damaged? It's prefabbed or a steel element or a rebar cage. We've looked to incorporate as much repetition as we can, so we can say pull a piece from a later phase, pull it forward, reuse it now, and then we can backfill the one in the later phase, and so we can keep the process moving forward.
Very good to hear. So the way my brain is kind of summarizing it is that this type of project delivery, we say in the industry, like measure twice, cut once. You're already doing all that measuring, pre-measuring. Everyone's bought into that phase of it very, very early. So that in and of itself is like de-risking changes later on.
And
So
I do think yeah, it's also, Aaron, you just made me think of something as well, is that,
yeah.
The speed to market, there's a lot of like, to Tim actually, like the larger pad, right? Because we can't pick the equipment right now, right? But we want to get it ready. The critical path says we need to make this decision now. Let's make the decision. You may end up pouring a 10% larger pad than you needed, and it's like, okay, that looks like waste. But if we can move that much faster every day that these clients and owners are open, a day sooner, that's how many more dollars that is contributing to their pro forma. So there's a little bit of like looking at the holistic business case of, if I get more time, if I open up 3 weeks or 2 months or 6 months earlier, what does that dollars look like versus some added dollars in construction material potentially?
And the material, like you're thinking of concrete, you might be pouring a little more concrete, but you also might be using less formwork and less labor to install it. And so you have to be thinking about how it will actually be built. And that holistic sense comes back again. Whereas if I'm just trying to minimize concrete or one specific variable, you're overlooking the complexity, how it's being built, and the extra costs that support its construction. And then there's the risk that any minor change then has to get back approved, go through the whole process instead of a slightly larger pad to begin with.
So prepare for supporting the bigger picture from the beginning.
Mm-hmm.
Yeah, if I could just comment on that, GPOA started, and DPR is part of, and GPOA are together now. But when GPOA was started many years ago, that nice logo that Tim has there for GPOA, that's representing the Renaissance Design Group, right? Which is this master builder vision, right? The master builders from the Renaissance period. You're looking at how the whole building is built, not just from a design perspective, but from like constructability, and like you said, formwork could be, you got to factor that into the concrete. That's really the vision here. I see that, DPR and GPOA are doing, which is really amazing. It's looking at the whole integrated approach to really speed up the delivery.
I just mentioning the Renaissance just like took me back, like, oh my gosh, we really are in an industry that's been around like literally forever. And now we're talking all these sorts of technical deliveries that I don't think anybody would imagine would be possible years and years ago. So just extra appreciating what you guys are able to achieve. So speaking of where we're at now and like how far we've come, we have an interesting question from Sandra on robotics and how this may tie in to the whole process. So for Sandra, coming from a robotics perspective, the need for an aligned model early is what's needed for true robotic integration. How has robotics entered your conversations and processes so far?
Yeah, I can speak to that. So we use a robot called Dusty, and so what Dusty does is we import or we upload to it essentially the layout. Once the slab is poured, every interior partition, every door, everything that's touching the slab, Dusty will take that file and go lay out every single line for us. And what I think, and it's like, that's really awesome. Number one, just because it can work later in the day than our trades. We still have people coming in the morning, QAQCing it, but it really extends the duration of that day, what's happening in a typical day. On top of that, the robot, right, has to have clear and concise information. And I think everybody on this call in the construction industry has dealt with, where does the architectural wall line live? Where does the drywall stud wall line live? Where does the structural shear wall line live? and they're 3 different places or 4 different places, right? And so I think leveraging these advanced technologies has really forced us to kind of come together and really get to this clean federated model because of the use cases downstream versus in the past, it's just we'll let it ride. It's an RFI. Somebody will get into the field versus we know the second the slab is cured and ready to walk on, we're out there with a robot laying out all of those lines to be built. So I think that's one thing that we've been pretty consistently scaling in the company for a couple of years now. That's may not seem like a huge deal, but it's really helping us out
Yeah.
when it comes to efficiency with our interiors.
Absolutely. So yeah, thanks for that response, Chad. Thanks for the question, Sandra. Before we move on, anything else to add to that robotics topic, Michael, Tim?
Yeah, just say that in some of the industries like the structural steel industry, they're very robotic already, like in the manufacturing space. The more these 3D models are
Right.
built early, the benefits to streamline it. So like when Tim said he had mill orders in 2 weeks and then fabrication in 5 weeks, if you don't have those CNC machines driving that process, like you're not going to achieve those schedules. So it's picking, subcontractors that are using the latest technology with robotic, there's robotic assembly of systems with welding and fabrication that they should be using.
All right. And I
Yeah,
think,
and they
oh, yeah, go
they
ahead, Tim.
I was just going to chime in that the high quality, what we call HD BIM, these high quality models that pull in all of the constructible, accurate field data allows all of these processes downstream, whether it's prefabrication or robotics. But if you don't have that high quality data, you can't leverage it in all of these new ways. And so it all starts with making sure that what we're designing and modeling and detailing from is a singular accurate model.
Okay. So I think this topic specifically or train of conversation has been really interesting. So we have another comment here from Dicey, and it's a little long here, but looks like we do this with processes, probably referring back to something else, maybe the integrated delivery with collaborative planning. Design locks are required from the team before material is procured. Oh, okay, so this is like de-risking the changes. Easier said than done, but that's an oversimplification. When design isn't locked and validated, we complain a lot on the ops side. Yep, I think builders especially have experienced that and remind the business how much changes will cost. The design team doesn't always understand what it takes to operationalize the design, so we have to educate as well. So this is actually a really good comment. Maybe if you guys could talk a little bit about, just educating the entire team about this collaborative approach. How does that work? So let's say, we haven't been building with these early connected model delivery types, I would say, very long. It's something relatively new, even though the technology has been out. So how is that learning curve going for you guys?
Yeah, maybe I'll take this one. So we and Dicey, a good point, right? And I think the reality is a lot of things are lost in translation between the design and engineering teams and our trade partners and fabricators. I think what happens is, well, I need floor plans. It's like, well, you don't actually need floor plans. What you need to know where all the rated walls are right now and like lock in those justification lines for those walls. And then in a month later, you need the interior part, the demising partitions with STC ratings. Then 2 months after that, you need everything that's recessed in those walls and all the fenestrations, doors and windows. And so I think what we've been trying to do is, and it's depending on the design partners, it's some more accepting than others, is really trying to get to like this kind of like incremental release of design information rather than just saying I need wall lock. Well, we don't need wall lock right now. Actually, let's ask for what really is driving the procurement, or what really is driving maybe an incremental permitting strategy that's separating out core and shell from a TI, from a fire alarm MEP separate package. So I think as an industry, we're getting a little bit. The builder side is becoming more and folks like me who came from the design side are helping help the builders understand how design works. And also, I think the designers they're recognizing that they have to, it can't just be, well, wait 6 months and I'll throw something over the fence to you, because then the project doesn't get built, right? And owners aren't paying twice to redesign things that they can't afford. They're getting more savvy as well. So I think it's a lot of just language barriers, and
Mm.
do you have a process to memorialize the design release incrementally rather than just saying SD, DD, CD? Okay, that's all we're going to get.
That makes a lot of sense in my mind. So it's basically, yeah, making it all comes back to that collaboration piece, right? So getting everybody together on the same page. So we have another question, and thank you, audience, for being so engaged. We love to see this from Jonathan, and this is I'm curious to hear the response. So, with such an emphasis on speed to delivery for data center campuses, is cost taking a backseat to delivery schedule? So, there's always a balance with how fast we produce versus how high that cost is going to be. What seems to be the more demanding metric?
I would say for our recent ones, it's a yes, but also a no. So yes, in that in order to get that upfront speed to market, you are emphasizing speed when it comes to being more efficient with upfront costs. And so if something is going to slow down the critical path but cost a little more upfront, you do the one that's maintaining or accelerating the critical path. The asterisk to all that is when you have your data center open 5 months early, the savings and the operational benefit from that far dwarfs any incremental cost that you have spent upfront. And so you do have, you have to make sure you have, enough funding upfront to build the data center, but once it's operational, the savings resulting from it is much outweighs whatever incremental costs you did to speed it up.
Yeah, there's the market's also pretty volatile right now with the tariffs and other dynamics. So I think the sooner that you can lock in material and procurement, you're just building durability and certainty into the cost of your project, which it's hard to quantify that because we don't know what's going to happen in a month. And so there's to Tim's point, there's cost savings on operations opening earlier, and there's also just some certainty in your material and equipment costs.
So I have a follow-up question to this then. Are we seeing that data center project delivery is one of the more predictable project types in the industry? Just curious to see if you guys have noticed any trends.
Yeah, I mean, I would say yes, and I'm with Tim. There's like always an asterisk, right?
Yeah.
When the data modules themselves are changing in functionality, like pivoting from a traditional cloud computing to AI, I think there's these kind of bigger shifts versus these clients' in-house engineering teams really fine-tuning little knobs, little dials on their systems. I would say it is more predictable than say healthcare or higher
Right.
education.
Right.
But there are these kind of big fundamental shifts that have happened recently, and I'm sure there will be another big shift in a couple of years that's similar.
And the general layout, the general functionality of a data center is relatively similar, but everything is scaling up to such a large extent for AI that you're fitting so much more cooling operation in order, because the megawatts for these campuses are just dwarfing everything out. It's like you're putting in a new campus that has the same capabilities as the rest of the data centers in the state. And so, it's just so much different. While the general layout and makeup of a data center is largely the same as 10 years ago. It's now at a different scale, and so you are solving new problems, and it's not just kind of the same thing that you're rinse repeat over and again.
Gotcha. So still some complexity there.
Mm-hmm.
Yeah, it doesn't surprise me in construction because there's always something new to learn, it seems like. So, speaking of like different project types, how does, or, do early, does early connected model delivery apply across other project types? Are we able to translate some of these schedule gains to other types of building, or is it really just suited for data centers?
I mean, I can say too, from my experience, seeing other teams doing this around the U.S., it most definitely is scalable across different projects.
Mhm.
And you see large EPC customer, turnkey general contractor engineering, engineer procure, uh, construct. They've been doing this for over 20 years in their, energy sector, right, or materials handling. The building industry with, we've seen healthcare projects to airports to data centers to school projects to smaller facilities. So big and small, commercial skyscrapers. The benefits are really scalable and repeatable on all project types. So I think, but like the gentlemen were saying, if there's some repeatability, of course, that has, the sophistication of the owner can just further magnify that impact.
Talk more about that, Michael. The sophistication of like the team, the owner. How does that unlock, more opportunity in the delivery method?
Well, I'm thinking of what like Chad and Tim were saying about the
Mhm.
owners, like say data center owners are maybe more, hope I don't get myself in trouble here, sophisticated, but because
Maybe a little more
if
because they're
there's kind of
from tech.
yeah, independent of the trends that are
Mhm.
happening, mega trends that are kind of redefining it, but just they know what they want, versus if you're doing a
Okay.
healthcare facility, maybe the clients, they're not familiar with construction, capital
Right.
project work and
Right.
how they need to make a decision. I think a lot of owners, they don't know what they don't know, like, or until they see it, right?
Mhm.
So,
Yeah.
and that just comes with experience too, but it comes too with a good architectural team and design team that knows how to shepherd the decision making with their clients and kind of getting, information out from them, for making the right decisions. So there is a good synergy between owner sophistication, I think, and the right design team. And
Yeah.
yeah.
And Tim and I just recently multiple projects actually with a single healthcare owner, very sophisticated healthcare owner, where we are getting a fabrication level of detailing during program validation, and
Hmm.
that's it's like what how did you do that? How like why would you do that?
Yeah.
And I think
How did you do that? Like, wow, that's
so.
early.
I
Really
think
early. Yeah.
yeah, and so we're representing spaces like a typical exam room with just a diagrammatic block, and the healthcare owner has a template to back that up, so we know the general size of that block, and we're
Hmm.
rearranging blocks, and we're saying, hey, those 6 blocks that are in that corner, this is an adaptive reuse of a building. Um, let's detail the heck out of those over there, right? Every Thursday morning for 5 weeks in a row. Well, in order to do that, you got to go pay the detailers and the fabricators. So we're talking to the owner, like, hey, if we can really inform the design intent of these exam rooms with this fabrication level of detailing, individual studs, brace frames, joists, kickers. We're saying this: if we can do this right here, we can scale these decisions across the 180 other exam rooms that you have in your project. And so we were able to do that over the span of like 2 months. And when we handed in the validation set with a program, we had some sheets that said these are the
Hmm.
rules that we're going to follow when we're going to build this building. And it was really kind of some next level innovation, and the client enabled that through the early, essentially onboarding of these fabrication level folks.
Right.
And so it was really kind of next level, and we could do it because of our GPL and DPR and one, we're the same company. And so we kind of had it in our back pocket to really just go and execute the next day.
Amazing. Would
Yeah,
it be
one
fair to say it's a like a virtual mock-up essentially that you guys or digital mock-up?
Yeah, it is, but
Rules.
it's also, I think it's the intent isn't to like, I mean, obviously a tangible benefit and outcome is you can see it visually, but
Mm-hmm.
the intent of it is really to inform the design intent, right? So how would we
Yeah.
change the design intent and the layout of these rooms with our construction means and methods, or prefabrication as well? We've got OR prefab ceilings baked into the validation. We got prefab post and panel walls baked into the validation. Tim, I think was about to talk about that a little bit more too.
Yeah. I didn't want to cut you off there, Tim. No, you had a thought.
Yeah, no, you can look at the design methods to integrate strategic wins and say, okay, what if we thought about it differently? Instead of everyone doing their own piece, and ducts have their own bracing, piping has its own bracing, the wall and ceilings have their own bracing. What if we design the wall systems to support the ducts, to support the piping, to support, and so there are only specific instances of braces, or it's going up and through specific posts that have been coordinated. And so you're minimizing all of that extra coordination, all that headache in the field, and greatly simplifying it just by thinking, hey, instead of just every trade fighting for themselves, how about we kind of work them into these multi-trade either racks or wall systems to better integrate the delivery.
Yeah, maybe just to add one more thing to that, I think our this so I anybody who's a VDC or BIM nerd like I
Yeah.
can't stand the word clash, right?
Oh,
And
tell me more, because like that's
on
all I
that
hear when I'm in
yeah
the BIM
on that
space.
project we didn't need to clash because we provided intent. We created rules of where systems would live and a lot of if then statements. If there's a primary duct going down the corridor, then the piping and gas are over the exam room or over a room, right? And it's going to connect here, here, and here. And so what we had initially scheduled for like I think it was 4 to 6 months of coordination, we did it in like 5 weeks or like a month, because everybody, when they populated their model, they already had a place to go. It wasn't throw the model in there, clash it, let's see what happens. Now what do we do? And because we had the fabrication level of detail for a lot of these systems during the design, we already knew what to expect, right? And so now we're also out in the field, breaking all of our production rates and overperforming, going faster than we even thought we would be,
Wow.
because we're providing that intent so early.
Yeah,
And
when you're integrating together, it's more about clash avoidance. So everyone sees everyone else's, you're
Right.
working together, you know how everyone else is operating. And so it's not the traditional system, which is everyone designs in their own silo, and then hey, throw it into the BIM guy, he will put it together, and we'll do clash checking sessions, and you have 1 million clashes,
Yep.
and everyone just is so disappointed, and then no one wants to redo their work, but it's then this big fight where everyone now has to do the design a second time, actually considering everyone else's, and then you work through these million clashes. Whereas if you talk up front and you say, okay, this is the criteria, these are the rules that you're going to follow, these are the ones I'm going to follow, then everyone is working together along the way, and you diagnose all these issues, and maybe at the end there's a handful of them left that you tackle.
Yeah.
But it's an avoidance, not just a check at the end.
Yeah, and I'd say that's a very important part. It's like root cause analysis. Like this process goes to the root cause. You could think of clash detection, like Tim was saying, 1 million clashes. That's more symptoms. Like you're using technologies to solve the symptoms, but you're not going to the root cause. If you're delivering these high definition models with all this data and you're coordinating it early, you're going to the root cause of the problems. You're resolving them as you go, and that's a key impact on schedule, but also cost.
amazing. So we have one, I think, question or comment here from saying all of this. And I believe this is, I can see it on my other screen here. It's Deep So how can we integrate and simulate AI and technology like VR, so like more technology and other things to streamline projects in a live manner? So the way I read this is, how do we bring technology to our jobs so we have like real time feedback and coordination? Because the issue faced on site is coordination.
Yeah.
So yeah, how do you bring in new technologies?
So on the AI front, it's interesting. We are, experimenting with a company right now that when we create these rules, when we're creating these opportunities for these deep dives, and we're creating these rule sets, we're essentially creating a more informed language model, right? And
Mm,
so so creating these, and we're trying to come up with a term for this, but these like kind of project based data lakes that have real, it's consuming the BOD, it's consuming the OPR, it's consuming the engineering intent, and then it's providing options, right? And we can survey those options. So I think that's the next big step for us in my mind, is having this fabrication level of intent and us providing that initial step and letting a large language model consume it and say, I understand what you're trying to do. Now let me scale it, because the
yeah.
scaling is happening manually right now. It's something that we're looking at.
So what I picked up from that is just be really intentional with how you're using the tech to drive value, and then it really fits in nicely to whatever project you're going to implement it on, is kind of what I
Yeah,
got from that.
yeah,
I love that because there's been a ton of AI talk, and I feel like there's a million tools that do this and that, and we kind of get distracted. But if we really want technology to work for us, we have to think about critically, like, okay, what problem am I actually trying to solve by applying this tool?
yeah.
Yeah, when I
Yeah,
think,
and the
go ahead, Tim.
go ahead. No, go ahead, Michael.
I'll just say, when I heard Chad using that, I thought that was interesting language, like project data lakes and things. Is if you think of the generic, you know, large language models, Gemini's to the Chat GTPs. I mean, it's like, it'd be like your grandmother listening to this webinar and not knowing anything about construction. Like, is she going to understand some of these languages, even like what a field weld is or something, right? So you need to have that domain language, and that's what that project data lake will allow you to, have more accurate information. So I think what Chad is saying is on the right track. It's a much more targeted way of using AI than just using the generic systems out there.
Yeah.
All
Go
right.
ahead, Tim.
Yeah.
Yeah, I was just going to touch on the VR aspect, and that you could use it upfront in design and
Mhm.
give that opportunity to the owner to virtually experience the building with these HD BIM models, and walk around and say, give them the experience of being there. They might not be versed in reading drawings as much as the people in the construction industry, so that gives them that opportunity. There's also the field opportunity where you could give a VR headset or an iPad to a field worker, and they can see virtually what they're doing before they do it. So there's
Yeah.
no mistake of, oh, this goes here, this goes in first, these are the other things that I'm working around, because historically it's been a lot of whoever gets there first gets to put their stuff in how they want it, and now everything's been coordinated ahead of time, and you can easily see how they integrate.
Better than IKEA furniture instructions for sure. I love knowing what I'm going to do before I do it. Yeah,
Yeah.
100%. So just a quick reminder to our audience, we're in the last 10 to 10-ish or so minutes of the conversation. If you have any last questions, thoughts, or comments, please do use that comment or chat box. Even if we're not able to get to your question live, we will see it later and be able to respond. So just a quick reminder to our audience there. And then I do want to bring up, so no delivery system is perfect, right? And there are probably some challenges, some hurdles that come up with early connected model delivery. What are those challenges and how do you address them?
I could start off just saying, hearing it from different teams and seeing teams learning how to do this process. Firms who've been doing this for many years and the ones who are kind of just getting into the game. And I think trust is the first thing, right? So it's,
Yeah.
you think of like that's the base of everything. Trust between the owners and the general contractor and the engineers as kind of the first step, and them being all kind of aligned at the very beginning on expectations, and then the subcontractors that are going to be either receiving these models, or if they're contributing even non-contractually in the parts of this delivery process, just what their expectations are, and they trust the process. I know a lot of the teams I've heard from fabricators who've worked with the GPO DPRs, and they trust their deliverables, right, because they've been doing this for many years in the industry. So I think that trust is really key. It's really foundation.
It's huge. Yeah.
Yeah, I would also just add, I think there are procurement. So, if a design team, let's just say you're paired up with a design team, or maybe the design team is already on board with the owner and the builder comes in later. Traditionally, typically the structural engineer is going to get paid for some of these services that we're saying, hey, maybe the fabricator comes in earlier and they take over the engineering model, or maybe it's the other way. Maybe the engineering team takes over the fabrication model. But I think there is a little bit of like, whose cheese is it, and it's just, you have to work through it. And in most cases, the structural engineer of record and the fabricator are pretty quickly getting on the same page anyways. But it has come up in the past of like, well, I'm already getting paid to do this. Why would you get paid to do this? And so there is that back and forth that has to happen. If you don't have the chance to be in an integrated project delivery or design build or IFOA type of contract.
Yeah, I would never really think about like, oh, the whose cheese is it, as you mentioned, problem. But that is a really insightful one to be aware of for sure when going into this.
Yeah, we've pulled the shop drawing process for structural steel and reinforcing into the design, into our scope, but it's critical that we integrate with the fabricators and say, hey, these are how we produce the drawings, and we can meet all your standards as needed. And almost, hey, 99% of the time, their response is, that's great, because the shop drawing creation process is the hardest part of their job. It's the part they want to be handling steel, fabricating steel, erecting steel. The point where they're creating drawings, trying to interpret design drawings, asking RFIs, doing submittals back and forth. They're happy to push that to someone else, provided that they get that quality set of deliverables that they would normally expect. And so it's just working together as a team to ensure that.
Okay, great insights. Oh yeah, go ahead.
Just add to that that process that Tim was talking about, like this delivery process. What's interesting for data center owners or owners who build like globally, and majority of Europe, structural engineers deliver the shop drawings for the concrete and steel and timber actually as part of their services, just like GPOA does, right? So, and the way they talk about it is exactly as Tim said, though, the fabricators, and they meet with them to understand their needs too, as they deliver those shop drawings, because it's on the critical path. So this has been done for a half a century in Europe, right? So it's not some new approach. We're just in the US, I've had a couple decades here to refine the process, but it's a proven system, and it just makes more sense.
Proven system. Yeah. So we're getting a last couple of comments here. I want to share at least one more. So from Paul, great insights from a powerhouse panel. I agree. Early connected model delivery has redefined collaboration, precision, and speed in delivering projects. Credit to DPR for aligning all stakeholders with the vision, which can be challenging. Yes. So thanks, Paul, for that shout out. Really appreciate that. And I also appreciate the insights from the panel. So to wrap up for today, I kind of want to go around and ask you guys to maybe pick one word that will describe the future of like data center construction, and then also share with the audience if they have a question or want to follow up, what's the best way to get in touch? So we'll start with let's go with Chad first, and then I'll do Michael and Tim.
I want to go last.
Okay, we'll skip. Michael or Tim, you want to jump in?
I mean, I just think that dynamic, it's like with this industry, it's changing mega trends wise, and the projects are very dynamic. But yeah, go ahead, Tim and Chad. Yeah,
I was going to say integration,
Integration.
just because it's that, this team here, the project teams, when you're pulling together across disciplines, across companies, that's what allows this to happen.
Yeah, maybe in the same vein, I would say nimble, right? We have to be able to pivot as new innovation. Michael's next, round of innovation that we have to be ready to consume, and just a lot of these projects last for multiple years, and so we have to be ready to take on new things mid-process potentially as well.
I'll throw out predictable as well for me. That's a huge one. So, all right. And then where can our audience find you guys? Or maybe Chad, or is it just LinkedIn?
Yeah, I don't check LinkedIn very often.
There you go.
I need to be better about that. But yeah, hit me up on LinkedIn. This will give me a good reason to tune in.
Cool. We got you on LinkedIn. Awesome.
Yeah.
Special sighting. Tim, and then maybe Michael to close us out.
Yeah, certainly reach out to me on LinkedIn. I'm there more than Chad is, but not necessarily that much more. But certainly reach out to me. You can also connect through our website.
Yeah. Awesome. And then Michael, with QNect. So tell us how folks can get in touch with you if they're like, hey, let us know more about this technology and delivery stuff.
Yeah, so I just reach out to me on LinkedIn. That'd be a great way to connect and answer questions, or how you can apply this process to your data center projects. And we're a service provider. QNect is, we work closely with DPR and GPOA and other engineering construction teams. So, and we have some cloud technology that's kind of behind the scenes doing a lot of the automation. So we're excited to bring in DPR and GPOA here to talk about how they're really leading the edge here. And so if you have some data projects coming up, and this is the right team to help you take a look and see if we can be more agile and nimble and
100%.
and more integrated.
There we go. And predictable.
Predictable.
So last comment here from Jeff, so much value. Why wouldn't every project go this way? I love ending on that note. It does make us think a bit more critically, like the traditional methods may not be the best, or may not, suit the nature of the industry that we're facing today. So with that comes change and trying new things, and I guess better execution. So yeah, really love that. So for our audience as well, this will be recorded on the LinkedIn page. So if you want to come back to it or send it off to some colleagues, it'll be here recorded for you. And I want to just say thank you to our fantastic panelists today. This was really interesting. I learned a lot more about data center coordination and how to do it well from you guys, just from the time that we had here today. So really, really appreciate your time and your insights and your expertise. And with that, we'll end it here for today. Thank you, guys.
All right.
Thank you.
Thank you.
Thank you, Aaron. Yeah.
Yeah.
All right.